Welcome to homework.
For this question, for part A and B, we were asked to show a couple of different relationships. So for one, we were asked to show that little d is equal to the square root of big D times big D minus 4 times the focal length, and that the magnification M2 divided by M1 is equal to big D minus little d over big D plus little d all squared. Okay, so let's go ahead and start with the first one. For part A, so let the object distance be P so that the image will be image I distance will be equal to big D or capital D minus P. So that's capital D minus P for I. Okay, so now we can go to the equation that says 1 over F is equal to 1 over I plus 1 over P. And we can replace I with D minus P. So this is equal to 1 over D minus P plus 1 over P. So we need to get a common denominator on the right side of the equation. So we're going to multiply through by D minus P over D minus P and by P over P. And we do the same thing to the left side of the equation there. Whatever we do to one side of the equation, we do to the other. So what we end up with here is P times D minus P squared is equal to, so we're just simplifying that equation. It's equal to F times D plus, or excuse me, F times D minus F times P plus F times P. So we're going to get everything onto one side of the equation and to put things in terms of P. So we have P squared minus D times P plus F times D is all equal to 0. Try to distinguish these D's from zeros so they don't look like zeros. There, okay. So we can use our quadratic formula then to find P, and we find P is equal to negative B, B here being D, right? Because it's negative B plus or minus the square root of B squared minus 4AC all over 2A. We know the quadratic formula, so this would be D plus or minus the square root of D squared minus 4 times D times F all over 2. Okay. So then we have, we're going to have two values for P. We'll call it P1 and P2. So P1 then would be D minus the square root of D squared minus 4DF, or D times D minus 4F, all divided by 2. So there's P1. And then P2 would be the other one. So this is going to be equal to D plus the square root, I forgot my parenthesis there, of D multiplied by D minus 4F all over 2. And we're asked to find the equation, or we're asked to find little d. Little d would be, it's going to be equal to P2 minus P1. And we know these values of P2 and P1 now. So we simply plug them in and we find the value for D then would be equal to the square root of D multiplied by D minus 4F. And that was the relationship we were asked to show for part A. So we can go ahead and box this in as our solution for part A. Part B wants to find the relationship for M2 divided by M1. So let's find the magnification 1. So we'll call this part B. And we only care about absolute value here. So this is the absolute value of the first magnification. And this would be equal to, since it's absolute value, we're going to ignore minus signs. This is going to be equal to I1 over P1. Or I1 over P. Okay. But here, I1 is equal to D minus P1. And P1 is equal to, so this would be D minus P1 over P1. And we can also replace P1 with big D minus little d over 2. So D is equal to, or P1 is equal to big D minus little d over 2. So then we'll replace P1 on the bottom with the same thing. This would be big D minus little d over 2. Or in other words, we find a value for M1 of big D plus little d divided by big D minus little d. And now we're going to do the same thing for M2, except for this time we have I2 and P2. So this is going to be, I2 is D minus P2, so this is going to be D minus P2 over P2. But this is, now we're going to replace P2 with values of big D and little d. So P2 would be big D plus little d over 2 divided by big D plus little d over 2. So simplifying this, we find that the value for M sub 2 would be big D minus little d over big D plus little d. So now that we know M1 and M2, what we want is the relationship between M2 divided by M1. So plugging in our values for M1 and M2 that we just found, we find that this is equal to D minus D squared divided by big D plus little d squared, or that ratio all squared. And that's what we were asked to show for part B, so we can go ahead and box that in as our solution to B.